Okay, so for the first exercise, we're going to program the operation of turning on and off of a LED. Okay, so as you know, um, every LED requires resistance in order to provide protection from any overvoltage that can occur in the circuit. Okay, so here we're going to place a resistance that is going to be connected to a LED. And if you can see, every time that I place a new device, configuration menu is displayed automatically. So here I can change the features or characteristics of my components. For example, in this case of the LED, I can provide a name or also change the color. You can use any color you want. In this case, in this example, I'm going to keep it red, just for use it as it is provided from the menu. Okay, and the next device that I'm going to use is the resistance. I'm going to provide the value of resistance for this element, and I'm going to be using 1 kilo ohm. I'm not going to change the value of that. I'm going to keep it just as it comes from the menu. Okay, so how am I going to connect these elements to the breadboard? It's quite simple, really. I'm just going to click on the element, keep clicking, and I can drag the element inside the breadboard, and I can place it wherever I want. It's just like it's the same as using breadboard in real life. Okay, so what I'm going to do is just connect the LED as if I'm going, just like if I'm going to connect it in real life, and I'm going to place the resistor in the anode element. So here you can see this is the anode and this is the cathode. Remember, positive and negative. And just for convenience, I'm letting the resistor in the anode. You could place it in the cathode as well. Just remember that you have to keep the polarity in each case. Okay, so if you are going to place the resistor in the cathode has to be connected to the negative power, and if you are going to place it on the anode, then your anode has to be placed in the positive polarity. Okay, so I'm going to keep it in the anode, and I'm going to drag it to connect the positive part of the breadboard to the positive part of my LED. And finally, here you are going to see that I can place the element even outside from the the breadboard. You could use it as it is outside from the breadboard, but for convenience I'm going to keep it this way. Okay, so I'm going to create connection from this point to the negative polarity of the LED, and I'm going to change this color to black just for not getting confused. And I'm going to start the simulation. You can see that the LED is automatically turned on. Why is that? Because here in the simulation you can see that the USB terminal is going to be connected to the Arduino board, and that is going to provide the energy and start the simulation for this board. So just as in the moment that this terminal is connected, provides power and of course energizes my breadboard. That's why the LED is kept turned on. But I have not programmed the Arduino board yet. I'm just sending the power just as it comes from the Arduino board. What I have to do is use these digital outputs to provide the instructions so I can control and change the operation from this LED. So that's what we're going to do. Okay, so after you have made this example, you are going to change the connection using keeping this negative wire as it is in the cathode, but you are going to change the resistor in order to keep connection from the anode. Okay, and you're going to send this part of the breadboard to the output number 2. You could use any number you want but just for convenience. You could use 1, 2, 3, etc. That doesn't make much difference. Just changes the programming that you have to do in the instructions for the Arduino. Okay, so I'm going to change this wire to red, just or maybe another color. I'm going to use orange in this case, just for representation of another function different from the red positive wire that we're using down here. Okay, so now this wire represents a signal. Okay, I'm going to keep it orange as well in here. Just give a click, change to orange. Now it is. Okay, so how are we going to give the instructions to the Arduino to keep different operation for this LED instead of just being always turned on? For that, we're going to use the programming that is available in this button upside in the left side of the simulation button. Here in code, you can see that series of instructions or catalogs or different menus is displayed. Okay, so this is what we are going to use in order to provide the instructions for the Arduino card. Okay, the basics are the output menu and the control menu. The output represents all the functions that the digital outputs can do, and the control menu provides all the conditions that are going to be changing the behavior of that output. Okay, so I could say that I don't know, maybe output number 0 in high. Remember that digital outputs are controlled by high and low states. Okay, maybe you could use it, or you could say that it's the same as 1 and 0 if you remember your digital electronic classes. Okay, so here we're going to build a new menu. How can you use this, or how can you move these different instructions that are appearing by default? Okay, just like the elements in the workspace, you are going to keep clicking on these elements. Your little hands works just like the hand in AutoCAD, if you remember. You keep a click and then you can drag those elements inside this trash can. As you can see, now we have a new blank space for the block diagrams to work. Okay, so first of all, you have to declare what is going to be your working element. In this case, remember, we said that it was going to be the digital output number 2. So here it is connected to output number 2. So I'm going to select this instruction. This is going to represent the condition of behavior of this output. Okay, definir pasador 0 en alta could be translated as define output, or maybe define the digital output number if I have connected, if I have placed my connection wire of my working element, my actuator, in the digital output box number 2, so I have to select the corresponding output. Okay, so I have placed now how it's going to begin the program or the instruction. Here, high, it's going to be on automatically. Okay, it's going to be turned on automatically in if there's no any other control condition before that. Okay, so what we're going to do is just keeping turning on and off every second. How are we going to do that? You could say that it starts or begins turn on or turn off. It doesn't change anything. It's just going to change the starting state of this LED. Okay, so it's going to be starting in the on position, and after that I'm going to use a new control instruction. What is this going to do? It's going to keep the LED turned on. It's going to wait on 1 second, and then I'm going to say that I'm going to change it again, but I'm going to change it to the off state, and that is what the LED is going to keep doing indefinitely. Okay, to the infinite times.